A relation R from A to B is said to be a function provided the following two conditions are satisfied. First, every element of set A has an image in the set B, and second condition, no two elements of B have same pre-image in the set A. See, for example, this is a set A and this is a set B, and there are 5 elements in A and 5 elements in B. Each and every element of A is related to some elements of B, that is, every element of A has an image in B. Whether there are only 5 elements in B or more than 5, because this is not necessary for B to have only those elements which have pre-images in A, there should not be any element in A which doesn't have image in B, though there may be some or many elements in B which do not have any pre-image in A. So every element of A has an image in B. So we see 5 elements are there in domain. Each and every element has an image in B. So there are some extra elements which are not images of any elements of A. It doesn't matter to be a function. And the second, no two elements of B have same pre-image in set A. So as you see, each and every element of B has a distinct pre-image in A. That means there are no two elements in B which have same pre-image in A. So this is a function. Now take another relation, and there are 5 elements, out of which 2 elements have a common image in B. Rest of the 3 have distinct images in B. So in this case also, the relation is said to be a function because every element of A has an image in B. That means there is no element in A which doesn't have image in B. And second, no two elements of B have same pre-image in A. Though two elements of A have common image in B, but this is not the restriction. Any 2 or more than 2 elements of A can have same image in B. So both the conditions are satisfied. So this relation is a function. Now let us take third example. Say this is a set A and this is a set B, and a relation is defined from A to B such that there are 4 elements, say 5 elements in B, and suppose 2 elements of B have a common pre-image in A, and rest of the elements have distinct images in B. So the first condition, that there should not be any element in A which doesn't have an image in B, that is satisfied because each and every element of A has an image in B. But the second condition, that there should not be any element, any 2 elements in B which have same pre-images in A, this condition is not satisfied by this relation to be a function, because there are two elements in B, this and this, which have same pre-image in A. But the second condition was no two elements of B should have same pre-image in A. So the second necessary condition for being a function is not satisfied by this relation. So this relation is not a function. Now to understand better, let us take one more example. The sixth element of A doesn't have an image in B. The first criteria to be a function is that there should not be any element in A which doesn't have an image in B. But we see there is one element in A which doesn't have an image in B. So the first criteria of a function is not satisfied by this relation. So this relation is also not a function. So if the first criteria is not met, we don't have to check the second criteria whether it is satisfied or not, but the relation may not be a function. Before moving ahead, we must understand the concept of range of a function. So let us talk about range of a function. Let f from A to B is a function. Then, as we have explained, that A is said to be domain of F and B is said to be codomain of F. What is range? So basically, range is defined as the set of those elements of codomain which have pre-images in domain A. The set of those elements of codomain B which have pre-images in domain A. For example, A is domain and B is codomain of a function f where there are four elements and there are six elements in B: y1, y2, y3, y4, y5, y6. x1 has image y1, x2 has an image y2, x3 has an image y3, and x4 has an image y4. So y1 is said to be image of x1 and x1 is said to be pre-image of y1. This is the way to name them. So x1 is pre-image of y1 and y1 is an image of x1. In the same way, x2 is the pre-image of y2 and y2 is said to be image of x2 and so on. So as you see, the whole A is said to be domain and whole B is said to be codomain. But range is the set of only those elements of codomain which have associated with the elements of domain A, or in other words, those elements of codomain B which have pre-images in domain A. There are four elements in codomain B, y1, y2, y3 and y4 which have pre-images in domain A. y5 and y6 have no pre-images in domain A. So range will have only those elements of codomain which have pre-images. So y1, y2, y3 and y4. So this is the set which is said to be range of the function f. If a function is from A to B, the set A is called domain of function f and B is called codomain of function f. The functions can be classified in two ways. First classification is based on domain and the second classification is based on codomain. So let us talk about both of them one by one. So first, the classification of function based on domain A. One possibility is that each and every element of domain has a distinct image in codomain B. Or in other words, we can say that no two elements of domain have same image in B. This kind of function is said to be a one-one function, which is also known as injective function. The second possibility is there are at least two elements in domain A which have a same image in B. There may be more than two elements which have same image in B, but at least two elements should have same image in B. Then the function is said to be many one function. And the second classification is based on codomain B. So if we take codomain under consideration, there are two possibilities for a function. Each and every element of codomain B has an image in domain A. And the other possibility is that there is at least one element in codomain B which does not have a pre-image in domain. If each and every element of codomain has a pre-image in domain A, then the function is said to be an onto function. And if there is at least one element in codomain which has no pre-image in domain, then it is said to be an into function. Onto function is also known as surjective function. Now let us talk about these four types of functions one by one in details. Let us define one function. A function f from A to B is said to be one function if every element of domain A has a distinct image in codomain B. Mathematically, this statement may be written as for all x1 and x2 belonging to A, such that fx1 is equal to fx2 implies that fx1 is equal to x2 only, and there is no other possibility for fx1 is equal to fx2. Now let us talk about many one function. A function f from A to B is said to be a many one function if at least two elements of domain A have same image in codomain B. Mathematically, for at least two elements x1 and x2 from domain A, fx1 must be equal to fx2, though x1 is not equal to x2. Now let us talk about onto function. Let f is a function from A to B, then it is said to be an onto function if every element of codomain B has a distinct pre-image in domain A. That is, there should not be any element in codomain which doesn't have any pre-image in A, then the function is said to be an onto function. In other words, if each and every element of codomain B has a pre-image in domain A, that means the range of the function must be equal to codomain. F from A to B is said to be an onto function if range of F is exactly equal to codomain of F. That is, range is equal to B. For example, this is domain A and this is codomain B of a function F. And each and every element of codomain has a pre-image in A. That means there is no element in B which doesn't have a pre-image in A. So obviously, each and every element of B will be included in the range, and range will be exactly equal to the codomain. Suppose these are 5 points P1, P2, P3, P4, P5. So the codomain of F is the set B, and range is equal to element P1, P2, P3, P4 and P5, because every element has a pre-image. So obviously this set is the set B, the whole codomain. So in that case, the codomain and range both are equal to each other. So this kind of function is said to be an onto function or a surjective function or simply a surjection. Now let us talk about into function, which is very easy to understand because the simplest definition of into function is a function which is not onto function is said to be an into function. But if we want to define this, so we say a function f from A to B is said to be an into function if range of f is not equal to codomain of f. For example, say A1, A2, A3 and A4 are four elements in domain which have images in codomain as B1, B2, B3 and B4, and there is at least one element B5 which has no pre-image in domain A. So obviously here codomain is the set B as a whole which has 5 elements B1, B2, B3, B4 and B5. But in range there will be only 4 elements B1, B2, B3, B4, not B5 because B5 has no pre-image in A. So these 4 elements will be included in range which have pre-images in domain A. So obviously a codomain has 5 elements whereas range has only 4 elements. So obviously range is not equal to codomain in this case. So f is an into function. Now what is bijective function? A function is said to be a bijective function if it is one function as well as an onto function. So if we need to prove that a function is a bijective function, we have to prove that it is one function and an onto function as well. Now I will explain how to check whether a function is one or not. So if f is a function from a to b, then we take two arbitrary elements, say x1 and x2, from domain A, such that fx1 is equal to fx2. We assume that fx1 is equal to fx2. Then we simplify this for establishing a relation between x1 and x2. So from 1, if we get only one result, that is x1 is equal to x2, only one result, then we say f is 1 or 1 function. So let us take an example for understanding this. For example, fx is equal to x squared plus 3x plus 2. And f is defined from set of natural numbers to set of natural numbers, n to n, where n is set of natural numbers. So a domain is natural number and codomain is also set of natural numbers. So we take two arbitrary elements x1 and x2 from the set of natural numbers such that fx1 is equal to fx2. It implies that fx1, if we replace x by x1 in this function, we get x1 squared plus 3x1 plus 2 is equal to fx2. If we replace x by x2 here in this function, we get fx2. So fx2 will be x2 squared plus 3x2 plus 2. Obviously, these twos on the opposite side of equality having same signs are cancelled with each other, and we are left with only x1 squared plus 3x1 is equal to x2 squared plus 3x2. Then we transpose these two terms to left hand side as well. So we write x1 squared, and transposing x2 squared, we write it as minus x2 squared plus 3x1, and transposing 3x2, we write it as minus 3x2, and on the right hand side we get 0. These two terms can be written as x1 plus x2 into x1 minus x2, and out of these two terms we may take 3 common. X1 minus x2 is left inside the bracket is equal to 0. Now if we observe x1 minus x2 bracket is common, so we may take x1 minus x2 common, and after taking common x1 minus x2, we get here in this bracket x1 plus x2, and out of this term only plus 3 is equal to 0. So we have two possibilities. First, either x1 is minus x2 is equal to 0, or second possibility x1 plus x2 plus 3 is equal to 0. So we have two possibilities. X1 minus x2 is equal to 0, or x1 plus x2 plus 3 is equal to 0. From here we have x1 is equal to x2, or from here we have x1 plus x2 is equal to minus 3. So though we have two relations between x1 and x2 for fx1 is equal to fx2, but this is not a valid result, because as we know well, the domain and codomain of the function are the sets of natural numbers. We have taken these two arbitrary elements from the domain n set of natural numbers. So that means x1 and x2 both are natural numbers, and the sum of two natural numbers may not be negative. So this is not valid result. So we consider this absurd, and we have only one possibility, which is valid possibility we can say, x1 is equal to x2. So we conclude that fx1 is equal to fx2 implies that x1 is equal to x2. Thus, f from A to B is 1, 1 function or injective function. Now let us take another example. The same function from z to z. Now this time we have taken domain and codomain both set of integers. Though we are taking the same function x square plus 3x plus 2 as we have taken in the previous example. So taking two arbitrary elements x1 and x2 from the domain, which is z this time, the set of integers, such that fx1 is equal to fx2. It implies that x1 is square plus 3x1 plus 2 is equal to x2 square plus 3x2 plus 2. And as we have done in the previous example, simplifying this, we have two relations, and both are valid because integers are negative and positive as well. So the sum of two integers may be negative. So this result, which was invalid in the case of the set of natural numbers domain, it is valid in the case of set of integers as domain. So we have two valid results. x1 is equal to x2 or x1 plus x2 is equal to minus 3. So by the criteria, if we don't have only x1 is equal to x2 condition but some other condition as well, then the function must be a many one function, not one function. So in this case, f is not a one function. Now let us talk about how to check whether a function is onto or into. So let f is a function defined from A to B. First step, we find range of f. Now the question is how to find range of f. So in this context, we will discuss how to take range of f. First step is we write y is equal to fx. We name it as equation 1. We transform equation 1 into the form x is some function of y. Then we find those values of y for which x belongs to A. And these values of y comprise the range. Or in other words, we can say that the set of those values of y for which x belongs to A is a range. So let us take an example. Suppose f is a function from R to R minus curly bracket 1. R minus curly bracket 1 means all the real numbers except 1. fx is defined as 3x plus 2 upon x minus 1. Let us take y is equal to fx and substitute the value of fx, that is 3x plus 2 upon x minus 1. So now we have to change, or we have to transform y is equal to 3x plus 2 upon x minus y as some x is equal to some function of y. So for doing so, we have to take y is equal to 3x plus 2 upon x minus 1. Then we have to transpose x minus 1 to left hand side. We get y into x minus 1 is equal to 3x plus 2. Or we open up the bracket, then y will multiply both the terms. So we have xy minus y is equal to 3x plus 2, then xy as it is, and transpose 3x to left hand side, it becomes minus 3x, and we transpose the term of y on the other side, we have y plus 2, because on transposition y becomes positive. So taking x common out of it, out of these two terms, we have x y minus 3 is equal to y plus 2. So proceeding from this step, transposing y minus 3 to right hand side, we have x is equal to y plus 2 upon y minus 3. So now we have to check for what values of y x belongs to the set of real numbers, which is domain of the function. So obviously x is defined for all the values of y except y is equal to 3, because for y is equal to 3, this denominator becomes 0, and then the value of this fraction becomes infinite and not defined. So clearly x is not defined for y is equal to 3 only, or we may say that x is defined for all y belongs to R except 3, so curly bracket 3. So here range is R minus curly bracket 3, but a codomain is R minus curly bracket 1. So we observe that range is different from codomain. It implies that range is not equal to codomain. Thus, f is not an onto function, but an into function. And the example is, consider the function f from a to b, where a is given as r minus curly bracket 3, that is the set of all the real numbers except 3, and b is equal to r minus curly bracket 1, which stands for the set of all real numbers except 1, defined by fx is equal to x minus 2 upon x minus 3. And we have to examine whether the given function is a bijective function or not. We have to discuss first injectivity. So for injectivity, we need to take two arbitrary elements x1 and x2 from domain A, such that fx1 is equal to fx2, which implies that as fx is x minus 2 upon x minus 3, so fx1 becomes x1 minus 2 upon x1 minus 3 is equal to fx2, which is x2 minus 2 upon x2 minus 3. We have to transpose x2 minus x3 to left hand side, so it will multiply x1 minus 2, and x1 minus 3 is transposed to right hand side, so it will multiply x2 minus 2. So we get x1 minus 2 into x2 minus 3 is equal to x2 minus 2 into x1 minus 3. We need to multiply these two brackets, so we have x1 into x2, x1 into x2, x1 into minus 3 minus 3x1, minus 2 into x2 minus 2x2, and minus 2 into 3 minus 3, that is plus 6, is equal to, now here on the right hand side, x2 into x1, x1 x2, and x2 into minus 3 minus 3x2, and minus 2 into x1 minus 2x1, and minus 2 into minus 3, that is plus 6. x1 and x2 on either side of equality having same signs, so these are cancelled with each other. Similarly, plus 6 on either side will be cancelled we are left with minus 3x1 minus 2x2 on the left and minus 3x2 minus 2x1 on the right. Now we have to transpose 2x1 to left hand side. So 3x1 was already here and 2x1 becomes plus 2x1 on transposition. So plus x21, and we have to transpose 2x2 to right hand side. So there was 3 minus 3x2 and it becomes plus 2x2. So we have 3x1 plus 2x1, we get minus x1, and on the right hand side minus 3x2 plus 2x2, we get minus x2. These minus are cancelled with each other and we are left with only one condition, that is x1 is equal to x2. So fx1 is equal to fx2 yields only one condition, that is x1 is equal to x2. Thus f is an injective function. We have shown the given function is injective function. Now we have to check surjectivity of the function. So for that we need to assume y is equal to fx or y is equal to x minus 2 upon x minus 3. So on transposition x minus 3 to left hand side, we get y into x minus 3 is equal to x minus 2. Multiplying inside, opening the bracket, y will multiply both the terms. We have xy minus 3y is equal to x minus 2. Now on transposing the terms having x on one side, we have xy minus x is equal to, so 3y minus 2. Taking x common out of these two terms, we have x y minus 1 is equal to 3y minus 2, or x is equal to 3y minus 2 upon y minus 1. Obviously x is defined for all the values of y, all the real values of y, except y is equal to 1, because for y is equal to 1, denominator becomes 0 and the value of x will be undefined. So clearly x is defined for all y belongs to R except y is equal to 1. So the possible values of y are R minus curly bracket 1, that is range. So range of the function is equal to R minus curly bracket 1. Now we compare with codomain, and when we observe the codomain, that is B, and B is given as R minus curly bracket 1, so that is R minus curly bracket 1. So it implies that range of f is equal to codomain of f, hence f is a surjective function as well. And since f is injective as well as surjective, so we may conclude that f is a bijective function.